All right, algebra students, I am going to work through this Unit 3, Lesson 2, Desmos activity, and we will start with my summer plans. There are 3 things on my list. I am taking classes at ISU, working on my doctorate, and I am going to Lake Geneva, Wisconsin for a week. Oh, forgot my comma. That will be the end of July, and then I want to sleep a lot because it's been an exhausting school year, right? Okay, so let's take a look at reviewing geometric sequences. Okay, so here is our sequence, 3, 15, 75. How do we get from 3 to 15 and from 15 to 75? What is our multiplier? So remember, we can determine our multiplier by taking one term, maybe 15, and divide it by the previous term. So 15 divided by 3 is 5. Does that work all the way through? I can check 75 divided by 15, and that too is also 5. So my multiplier, B, equals 5. So I am just going to put 5 in the box, and then I'm going to fill in the rest of my table. So 75 times 5, 75 times 5 is, that didn't do what I wanted it to do. All right, here, we'll use this one. 75 times 5 is 375. And then I am going to do that answer times 5 to get 1,875. All right, so now I have those numbers filled into my table, but what's my zero term? What's my zero term? I have too many calculators open. So if I were to back up a spot and find my zero term, if I'm multiplying by 5 moving forward, what do I do to work backwards? Okay, so going this way, we multiply by 5. So backing up, we are going to divide by 5. So my first term is 3. So my zero term, or my A value, we find by taking the first term divided by our B value. So for us, that's going to be 3 divided by 5. And I'm just going to write this as 3 over 5. Or you can use a decimal too. It does not matter. So if you write 3 divided by 5, that is equivalent to 0.6. So if you want to use 0.6, that's totally fine. I'm a fan of fractions, but not everyone is, so I get that. The only time I really encourage you to use the fraction is if you have a repeating decimal. Then it's cleaner, okay? So we write our equation T of n, because we are talking about a sequence rather than a function. T of n equals our A value, 3/5, times our, what am I doing? Times our B value of 5 to the nth power. Okay, and again, you are welcome to use 0.6. That works as well. Okay, but that is our formula. So what do we do with this? What's next? Well, let's find out. So once we know our equation, we can use that equation to find other information. We can find terms in the sequence. Like if I want to know what the 25th term is, I can use 25 for n and calculate that out. I can find if a number is in the sequence by seeing if it shows up in my list. Okay, so let's look at everything from our warm-up. 3, 15, 75, our multiplier was 5, the a value is 0.6, and then we have our equation. So using that equation, what is the 10th term? So let's use our calculator, and we are going to type in that 0.6 times 5, and we want the 10th term, so that means my exponent is 10. And that's a really big number. So let me move my face out of the way here. Okay, so we can type in that number. 5, 8, 9, 3, 7. Nope, I missed a number. See, 5, 8, 5, 9, 3, 7, 5. So 5,859,375. Ooh, that's a big number. Okay, now, is 46,875 a term in our sequence? Will it show up? So our hint here is to use the calculator on the next screen to make a table of values to help us determine. Okay, well, let me close this one out and let's go to the next screen. What I'm going to do is remember my formula, T of n equals 0.6 times 5 to the nth power. And I am going to type that equation here. Let me move my face again. Okay, T of n equals 0.6 times 5 to the nth degree. So that's our equation. Again, it's not showing up as a sequence because our sequence is only the points, but let's look at the points. Okay, now we are generally not going to look at the negative values, so I'm going to start this with my first term, and I'm going to change that to a 1, a 2, a 3, and we're just going to work our way down. Let me change these. 6. Okay, and I'm going to keep going. You remember what number we were looking for? Ooh, I think... What? 8, 9. Ooh, that's some big numbers. 10. All right. So we wanted to know if, let's back up a slide because I can't remember what number we were looking for. Is 46,875 in the sequence? So, 46,875 is in the sequence. That is my 7th term. Blow this up a little bit here. Okay, yeah, my 7th term is 46,875. So I would come back to my screen and say, yes, 46,875 is the 7th term. Okay, submit that. All right, I think I've got everything submitted here. Fantastic. All right, let's try another one. So our sequence, 5, 10, 20. What is our multiplier? How do we get from 5 to 10 to 20? So you may see that we are multiplying by 2, right? So my B is 2. No, my face disappeared. There it is. Okay. What is the 0 term? Remember, we get that by taking our first term and dividing by the multiplier. So this one is our first term divided by the B value of 2. And I can write this as 5 halves or as 2.5. It does not matter. And then what is my equation? All right, T of n equals, remember your equation is in the structure. A, our zero term, times b to the nth power. Okay, so T of n equals our A value, 5/2, or 2.5, times our B value of 2 to the nth power. Okay, what value is the fifth term? As in, what do you get when n equals 5? All right, so I'm going to pull up my calculator. And our equation, T of n equals 5/2 times 2 to the fifth. So I'm going to do 5/2, times 2 to the fifth power, and we get 80. Okay, so here I'm going to type in 80. And does the number 1,280 come up in the sequence? If so, when? All right, let's take a look. Let's go to the graphing calculator and take our formula. T of n equals 5/2 times 2 to the n. Okay, T of n equals 5/2. Oops, hold on. My parentheses in the wrong spot there. Times 2 to the nth degree. We're going to change this to a table. And again, we are starting with our first term. Third, oops, okay. All right, 4, 5. So we found our fifth term, and we're looking for 1,280. Well, let's find out. All right, so if I double this, that's 160. So maybe I want to skip a few terms. What happens if I hit 9? Ooh, all right. So 7, 8, 9. So you can see as you approach that we do get the ninth term showing up here. So let's see. Yes, when n equals 9. Okay, it is the ninth term in my sequence. It is possible for your answer to be no, it does not show up in the list. And when that happens, it's because we cannot have partial term numbers. Remember, our term number represents the location in the list. There's no in between. You're either in spot number 12 or spot number 13. There is no spot 12.5, right? So you want to keep that in mind. So now let's look at a scenario. Real world here. Suppose you start a collection of pennies. You decide to start with 1 penny and then double every day the number of pennies you have. So let's fill in our table. So day 1, we have 1 penny. Day 2, we are doubling this and we get 2 pennies. Day 3, we double that 2 pennies. So 2 times 2 is 4. Then we double the 4. 4 times 2 is 8. 8 times 2 is 16, and we keep going. Okay, so what is our multiplier? When we double, we multiply by 2. So our B value is 2. Our A value is our first term, 1, divided by 2. So I like to write things as fractions, so I put 1/2, but you can use 0.5, totally fine. And our equation then is T of n equals my A value, 1/2. Oh, I keep putting my parentheses in the wrong spot, times our B value, 2 to the power of n. All right, so we keep up this pattern for 31 days. How many pennies do we have on day 31? So if I put 31 in for n, let's see what we get. So 1/2 times 2 to the 31st power. Whoa, that's a lot of pennies. That's a lot of pennies. 1.07374182 times 10 to the 9th power. Now, if I want, I can shift my decimal point over to the right 9 spaces. So that's 3, 6, 7, 8. If I put another 0 there, I can go back and get rid of this decimal, and let's look at what we have. We have on day 31, 1,073,741,820 pennies. That's a lot of pennies. If I wanted to, I could say, let's see how much that is in dollars. And we can divide by 100. And now we have $10,737,418.24 just by finding 1 penny and doubling the number of pennies each day. I don't think I want to be carrying around that many pennies, but still, it's kind of a cool concept, isn't it? So let's take a look at another example. Another scenario. Any Walking Dead fans? So here, zombie apocalypse. Zombies are taking over the world, and every day the zombies infect 2 other people, tripling the amount of zombies that day. Okay, so suppose on day 1 there are 2 zombies. We start with 2, and they infect more people, and we triple by multiplying by 3. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. Ooh, the number of zombies is growing. The multiplier, we are multiplying by 3 because we are tripling each day. And then our 0 term we get by doing our first term divided by our b value. Now, if I do 2/3 on a calculator, that is going to give me 0.6 repeating. And this is where I definitely prefer that you use a fraction because it's cleaner. We don't have to worry about rounding. It's a precise unit, okay? So our equation then, our T of n equals our a value, 2/3, times our b value, 3, because we are tripling, and then to the power of n. By day 8, how many zombies do we have? And here I'm going to take our equation and just, let's just go ahead and create our table of values. Okay, so here we are going to change this to a table. We are going to start on day 1 because we are talking about sequences, right? So I'm highlighting instead of erasing. Oh, Mrs. Miller, what are you doing? Okay, here we go. So 1, 2, then we have day 3, day 4, day 5, and we want day 8. Okay, day 8 is 4,374 zombies. 4,374 zombies. 4,374 zombies. Because we are talking about units of measure and we are specific to the number of zombies, we may as well use the label, right? Now let's look at our list. Is there a day when we will have exactly 354,294 zombies? If so, what day will that be? Okay, so 3,000, you know what, I'm going to write this down because when I write on my screen, it will carry to the next screen. So I'm going to just write this, I think here, 354,294. All right, so let's see what happens. See, that number came. Let's see if we can find it in our list. Okay, so day 9, we're at 13,122. I feel like this is going to take a while. So let's see. Let's jump up to maybe 12. Dude, I am a good guesser. All right, maybe we jump to 11 just to get a little bit of wiggle room. Okay, so that's not enough. So then maybe I try 12 or 13. Okay, there we go. 354,294. All right, so that is in the list. So let me add one more question. So we know on the 12th day, there are 354,294 on the 12th day, right? Is there a day, or what day will we have more than, I don't know, 1,000,000 zombies? When will we have more than 1,000,000 zombies? So, I don't know, maybe I try 13. Ooh, I'm going to shift my decimal place over here. 2, 4, 6, and that is 1,000,000 right there. Man, that's more than 1,000,000. So on day 13, we have more than 1,000,000 zombies. Is there a day we will have more than 1,000,000,000,000? So that will be to the 9th power. So let's try day 14. Oh, we're still to the 6th power. Let's try 16. 7th power. All right, 19th. That's to the 8th power. And then 21. Ooh, I may have gone too far. So let's try 20. Okay, so from day 19 to day 20, we hit the trillion mark the billion mark for number of zombies. So trillion would be to the 12th power, so my bad on that. Okay, so let's see, 25. Okay, 28. Oh, that's too far. So 26. Yeah, so between days 25 and 26, we hit that trillion mark. And I don't think there's a trillion people on the planet right now. So I think we're safe. But just some fun you can have with using your table and guessing, looking for patterns, looking for when will we have this much, or when will an atom split this many times, or using half-lives with chemistry, when will we have like near zero grams of whatever substance. Okay, so there's lots of really cool application with this, but we just want to summarize that this formula, okay, T of n equals our zero term times our multiplier to the power of n. That's really what we use with the Desmos graphing calculator to generate those lists and to look for patterns and to identify those key terms, like finding the 10th or the 20th term in your sequence, or seeing if a number shows up there, okay? So I hope you enjoyed this and had fun. I sure did, and we will see you in class.